Welcome to the Vobii Starter Kit. We'll be taking you through our site on both the student and tutor ends. But first, what is Vobii? Vobii is an exam preparation platform that helps students get ready for math and science exams within a few hours. We started Vobii with a group of engineering science students at U of T for a simple reason. Exams are hard and time is very limited. The first year, we used to have 6 exams in a row and about 1 day to prepare for each. So, we searched for an efficient solution that could get us a 4.0 in every course. Unfortunately, we couldn't find anything. As such, we spent the first 2 years at university developing a learning model for science courses called the Concept, Example, Quiz, also known as the CEQ learning model. The Concept, Example, Quiz learning model is derived from the way we study math and science. There are 3 steps: the concept, the example, and the quiz. The first step is where we learn about concepts. This can come in the form of a definition, a theorem, a fact, or even a formula. At this point, we only know about the concepts. However, in order to truly understand them, we need to look at classic examples and use cases of these concepts to see the applications of our newfound knowledge. This is why professors go over questions in lecture, to engrave the content in our minds. After examples, we get a grasp of the concept, but this understanding fades out quickly. Thus, we need our last step, quizzes, to solidify our understanding and to learn how to independently put our knowledge into practice without assistance. With these 3 steps, we can be confident in our knowledge, understanding, and our application abilities of the learned concepts, all the while remaining efficient. Vobii is designed to give students a full learning experience through our Concept, Example, Quiz learning model. Now, let's take you through the student end to see from their point of view. First, log into Vobii.com as a student. You can log in using Facebook. Once logged in, you will see a list of all the course packages that we offer. One of the courses we offer is calculus, a well-defined subject that is taught just about the same way across all English-speaking universities. This allows us to break down calculus into hundreds of CEQ models, groupings of related concepts, examples, and quizzes. All of these models make up together the subject area of calculus. At each university, we can simply group the models and customize the course package based on their exam requirements. Let's enter the MAT 135 final package. When you first enter the package, you will be asked to choose a goal. When preparing for exams, different students have different needs. Some students who have missed most lectures will need to go through all of the CEQ models. Others, who already have a solid understanding of most concepts, can choose Fastlane to brush up on the most important concepts. About 25% of students cram on the last day, so going through past exams might be their best way to prepare. Let's choose full 4.0 so that we're prepared for everything and we know what we're doing on the day of the exam. Assuming our student users don't know anything about this course, we show them the 2 most important things that they should care about. 1, what the course is about, which is the course description at the top, and 2, the most prevalent topics on the exam, which is a pie chart that breaks down all of the topics that were seen on the exams in the past 5 years for MAT 135. After understanding the course breakdown, the student user needs to see where their weak spots are in order to allocate their time efficiently and get the most out of Vobii. This is where the diagnostic quiz comes into play. The diagnostic quiz is comprised of dozens of multiple choice questions, each one related to a unique model. That being said, whenever a student answers a question incorrectly, Vobii takes them through to the right answer and marks the model where it comes from for future reference. For example, if a student gets this limit question wrong, they should probably spend more time understanding limit laws. Thus, the diagnostic quiz allows our users to customize their study plans and focus on what is most important to them. Knowing their weaknesses, it's time for users to dive into the CEQ models and learn or review. Let's see how the CEQ models come together. On average, a course has around 25 to 50 CEQ learning models. Each model contains several concepts, usually 1 to 4, several examples, usually 2 to 6, and several quizzes, 1 to 3. For instance, in the product and quotient rules, we start with the concept of the product rule. A concept should contain an introduction to the concept to give some background information, statement of the definition, theorem, fact, or formula, a thorough yet concise explanation of the concept and additional insight to help students understand, written in the tutor's own words, and an image to help students visualize the concepts of the concept. After the concept, we need an example on the product rule to further understand its applications. An example usually contains a question, a link to the concept, a brief restatement of the concept, if it's necessary, a thorough step-by-step solution for the problem, and an explanation of the steps to solve these types of problems, if it's applicable. Note that a restatement of the concept might be a good hint to solving a question. Also, since we write content for students, we cannot skip steps as it will cause a lot of confusion for them and impede their understanding. Finally, we see a quiz on the product rule and another one on the quotient rule. Quizzes are very similar to examples, except for two things. First, students cannot access the solution to the question until after they have tried to solve it for themselves. They have to answer the quiz before the Show Solution button appears. Second, quizzes are generally more difficult in order to challenge the students to push their boundaries. After all the CEQ models, we provide past exams because at the end of the day, past exams are the students' best friends. They provide insight to the current year's exam, and they are the best tools to thoroughly test the students' understanding of the entire course. At Vobii, we usually prepare step-by-step solutions to 3 to 5 past exams, formatted the same way as examples or quizzes, to not only refresh their memory, but to also show students how to approach each type of problem. So as you can see here, we have a full past exam solution for the 2015 October midterm for Mat 135. The last thing on the sidebar is the formula sheet. The formula sheet symbolizes the completion of the Vobii review journey. After learning about the course structure, testing their strengths and weaknesses, completely understanding all the models, and practicing with the past exams, the formula sheet refreshes the students' memories of the entire course for the last time. So this is a formula sheet that we developed for Mat 135. They are now ready for the exam. Let's log into Vobii, as a tutor this time, using the URL vobii.com/tutor login. The first page we are shown is the CEQ model page. On the left, you can see your models. Again, the groupings of related concepts, examples, and quizzes. And on the right, you have a list of all of the concepts, examples, and quizzes available on our site where you can filter by subject, course, name, approval status, and author. To navigate the tutor platform, you can use the nav bar. If you want to find your concepts or create a new one, click the Content tab and you'll see a drop-down. The Concept button will take you to the Concept page. On the left, you will see all the concepts that you have created that haven't been approved yet, and on the right are all your concepts that haven't been approved. At the bottom left corner, you can click the New Concept button. Now we are on the concept creation page where there are several things to fill in. We have to fill in the name. The name of the concept has to be unique, concise, and specific. For example, product rule. Avoid vagueness and super long titles. Capitalization also matters. You can also upload an attachment. If you need an image to help illustrate your concept, this is where you'd upload an image. At the moment, we can only upload one image per concept, example, or quiz. If you have multiple images to add, we suggest you make a vertical image, not horizontal, and upload it as a single attachment. The subject is a mandatory field. Choose the subject that this concept falls under. In this case, we'll choose calculus. The course code is optional. You should only put it in when you're developing a test or exam solution for a specific course. Concepts usually should not have a course code. The content, or the second tab, is the body of your concept. On the platform, we use LaTeX to create our content, and here we have created the content for you. Links on the third tab is where you can link back to other concepts, examples, and quizzes that will help students understand what you have written in the current concept. All CEQs can have links. The way to include them is by inputting the corresponding ID numbers. If you open up a new tab, or Vobii.com, you will notice that all the concepts, examples, and quizzes are numbered. To view all of the concepts, examples, and quizzes on the site, just go to Content and then CEQ Models. And then here we can filter and find the specific ID of a concept that we're looking for. For example, if we want to learn more about the Fermat's theorem and critical number and link it back to our concept, all we have to do is specify that concept number ID 7 is going to be included in our concept. Once we're done writing our concept, we can preview it. We can click on the preview to see how your content looks and also preview the image. The beautiful formulae on Vobii are typed up using MathJax, which is a slightly watered down version of LaTeX. Don't worry though, LaTeX is not a programming language, it's a scripting language. There is next to no logic involved, so it takes less time to learn. LaTeX is mostly for formatting and to create symbols, like making matrices or the integral sign. Everyone should be able to grasp LaTeX within an hour, and after a full day or two of using LaTeX, it'll be second nature to you. There are two types of formula we can write: block elements, denoted here with a double $sign with a opening and closing tag. The formulas in here will take an entire line and will be spaced apart from the things above and below it. It'll be also centered automatically. So for example, if we're to just write something like f of x is equal to x cubed here, it'll preview in the window, in the preview concept window up there, as a centered and aligned formula. There are also inline elements, formulas that will naturally flow with the sentence. We have to wrap our formula with the corresponding opening and closing tags for a inline element. If we want to say that we have a function f of x is equal to x cubed, we can simply say we have a function and then write the formula inside here. And now we have a sentence where the formula is nicely formatted into the sentence. Usually with LaTeX, we can also denote an inline formula using a single $sign. However, this isn't compatible on our site because the chances of the $sign showing up on our web page is too high. In LaTeX, everything is a command. For example, the integral sign can be generated using the int command. And the limit can be used using a limit command. Almost everything you can do in LaTeX, you can do on Vobii.com. To fully learn LaTeX, some useful resources are available on the website. There are also some common problems with Vobii that aren't compatible with LaTeX, so please refer to those and ask any senior tutor or any of your peers for help.
The concept we will take you through is one for economics. Keep in mind that the structure of a concept may vary from subject to subject. We'll be going through an introduction for types of goods, so let's title this concept Introduction to Characterizing Goods. As I've mentioned, this concept is for economics, so let's choose that one in the subject dropdown. For course, we will leave that blank, since what we will be covering is something that is taught in a lot of universities. In other words, this topic is not unique to a single institution. Our concept has already been pre-written, so under concept, we will insert it in. When we hit preview, we can see on the left what it will look like from the student side, formatting and all. Before we save the concept, let's upload our corresponding image. We can do that if we go back to concept and click on Choose File by Attachment. If we go to image, we can also preview this and see what our image looks like. Now we're ready to go ahead and save the concept. Here, we can see a brief introduction right at the top describing what we're going to be covering in the concept, without going too much into detail. From this, we know that we'll be learning about how to differentiate different types of goods from one another. Under criteria, we specify exactly how to categorize the goods. Is it rivaling consumption? And is it good excludable? Notice that we have used a lot of text formatting, bolding, underlining, italicizing. When you come across a point or a term that is important, it helps students a lot if you can emphasize it so that they know what the key things to pick up and remember are when they are going through the concept. Also notice that below these questions, we have defined in our own words what the key terms in the questions mean. Some of our students see terms like these for the first time in our concepts, which is why it is very important we take the time to go over them again in our own simplified words. This reassures that every student understands what we are teaching them. However, just as mentioned before, this step isn't limited to only definitions. It also applies to formulae, equations, and anything else alike. If we go on, We can see that we go more in depth about the categories of goods and expand on them to explicitly state their own definitions in relation to the criteria given. All here. Finally, the image. Here we have a table that directly illustrates what we've covered in the concept. Images are good supports to help students visualize what you're writing. The image can be anything you want, so long as you make it yourself and it correlates to what you are writing, whether it be in the form of a table, graph, or diagram. Please make sure that you use programs or sites that allow you to use things created on their platform for commercial use. Now to wrap up concept creation. Think of concepts like you would an introduction paragraph of an essay. Start off very broad, then funnel down to specifics.
After you finish creating your first concept, the following steps are important and will need to be repeated for the later example and quiz creation processes. The first step is to check off your self-checking criteria. This includes reviewing your content, making sure you have the relevant background and introduction, that it's correct, that it's complete, that you have all of the necessary proofs, definitions, formulas, and derivations if they're applicable, and making sure that your work is original. We don't want to see any sentences, paragraphs, or photographs taken directly from another source. You also want to make sure that it's clear, that it's straightforward, and that terms and abbreviations are defined. We want to make sure that the writing, things such as grammar, punctuation, spelling, emphasis of keywords, and structure are all well done. And that the image, if applicable, is of high quality, is relevant, and is fully labeled. If a self-check isn't passed, a checkbox will appear beside the concept title on the concept page. After self-checking, if the senior tutor doesn't approve, you will get your feedback in the form of a comment. Then, 3 dots will appear in front of your concept until your work is approved. As mentioned, you will get your feedback in the form of a comment. When the team head or a quality assurance controller first goes through your content, they will leave comments if they feel there are improvements that need to be made. We know that it's tedious work going through everything that you will write if someone has commented, which is why that you'll get an email for every comment under your creations. Now, team leads and quality assurance controllers aren't the only ones that can leave comments. All tutors can leave comments under each other's work. The reason for this is because we do something called peer approving. For every piece of content you create, you must peer approve at least 2 other pieces of content. The way to do this is by reading content created by other tutors on your team. From here, you have 2 options. So as you can see here, I'm going to be peer reviewing someone's gravitational field concept for physics. If you see that the content is really amazing, you can go on ahead and click the eye icon on the right side of the page. Click OK, and now you have peer approved. However, if you see that the content needs some work, leave a comment detailing what you think needs some improvement. That tutor will get an email, and once they fix their content, they will reply, which in turn will send you an email. Once they've improved their content to a standard that you find acceptable, click on the eye icon, click OK, and once again you have peer approved. We ask you to be very critical when peer reviewing and approving. Not only will this help the other tutors produce better content, but it'll also help you understand the errors and weaknesses that are most common so that you can overcome them when writing your own content.
To create an example, first we must come up with a question to base our example on. These questions, along with their solutions, must be your own original work. Here, we'll demonstrate how to create one example. We'll take you through an example on logarithmic differentiation, a topic in calculus. Since there is already an example titled Logarithmic Differentiation in our database, we'll title this example Logarithmic Differentiation 2. Next, we have difficulty. Our scale goes from 1 to 3, 1 being easy, 2 being average, and 3 being hard. We feel that the current example has a difficulty of 2, so we enter 2 here. Following this is the Q image and S image. The Q image is the attachment used for the question, and the S image is the attachment used for the solution. Our example has no need for an image, so we'll skip this. For a subject, we'll choose calculus from the drop-down. Finally, we'll leave course blank as logarithmic differentiation is something that is taught in most of the universities. Under question, we'll type out the questions that we want to walk through with students. We'll be solving this problem. Previewing the question will let you see how it will format on the student's end. Now it's time to move forward to the Solution tab. We have a pre-existing solution ready to use. Again, if we preview solution, we'll see everything formatted the way we have scripted. The last thing to do before saving is adding links. If we open another tab for Vobii and search for the concept logarithmic differentiation, we'll see that there does exist a concept on the topic, and that its ID number is 32. Back on our original tab, under Links, choose Concepts. Type in the ID number and write a title. You can choose to title it the same as the original author did, or if you see that the title is too long and complicated, you can rename it to something else that you find more fitting. We'll title this link as the author did, Logarithmic Differentiation. This example needs only one link, so now we can save. Once saved, we can see the example as students see it. First, at the top, there's a tab. If you click it, it will show the complete concept that you linked to. You can toggle the link on and off to your liking, just as students can on their end. The link serves as an introduction so that you can start solving right away. If you would like to write a more distinct introduction, you can write a blurb such as, quote, "This example requires prerequisite knowledge on how to do logarithmic differentiation. Refer to the link above if necessary," end quote. We then go on to the body of the solution. Here we need to show all of our steps. There will be times when you think that you should omit steps because it seems so bluntly obvious. But keep in mind that not all students see things as clearly as you do. This is why we also ask you to explain in words your thought process on how to start your solution. Your thought process on how to overcome tricky obstacles where students are likely to get stuck, and some reminders of key pieces of information that students are likely to forget, all of which you can see in the example at the start, middle, and end. Finally, after you have finished your example.
Demonstrate how to create a quiz. Quizzes are modeled the same way as examples are, except for the fact that there are multiple choice options. Again, these questions and their solutions must be your own original work. So let's demonstrate how to create a quiz. We're going to go create a quiz on the topic mRNA export, a topic discussed in biology. When filling in the info for quizzes, it's generally all the same as the info required for examples, except that you will notice an extra box for answer, and other boxes for alternatives 1 through 4. This is where the multiple choice options go. The correct answer goes under answer, while the other 4 options go under the alternatives. If we go ahead and fill this in, we can title this quiz as mRNA export, and specifically export proteins. We won't be needing any question images or solution images for this quiz, but they are available should you need them. Next, I'm going to put the subject as a biology subject and leave the course blank. Generally, when creating quizzes, if they are created by you and not specific to any university or past exam or past test, this box will remain open. You will only ever need to write in it if you are creating a quiz specific to a university. Next, we'll go ahead and fill in the answer and the alternatives, all of which has been made beforehand. So keep in mind that the correct answer must go under answer and the wrong answers must go under all the alternatives. Just as with an example, we can input the problem under the question tab. We'll just paste that in and get on with the solution. Since we have the solution ready to go, we can also go ahead and paste that in under the solution. On to links. Since this question is quite lengthy, there's a bit of prerequisite knowledge students need to have before they can proceed successfully with this quiz. They'll need to know about concept number 718, which is mRNA exports, They'll also need to know concept number 713, specifically proteins associated with mRNA export. They'll also need to know concept number 715, the spliceosome. And lastly, they'll need to know concept number 710, RNA methyltransferase. We select the type of concept, example, or quiz, and we are done. After everything is done, we save it and we see how it looks to a student. The solution is, again, very similar to the example. As we can see, there's first a quick introduction outlining the necessary concepts, or the major concepts, that you need to know to answer this question. Then you have more insight on the question, perhaps a bit explaining how to go about interpreting the question, and then basic knowledge that would be necessary once answering the question. Then we have the step-by-step solution. So the difference between examples and quizzes is that for examples, you take students through the process of getting from A to Z the proper way the first time. With quizzes, you not only have to explain how the correct answer is right, but you also have to explain why the incorrect answers are wrong. We don't want to use the process of elimination for quizzes because this doesn't show students where potential errors might occur and where to fix them. Also, by explaining why the wrong answers are wrong, you give a more detailed explanation of some concepts that might not be touched on. In our quiz, we see that each option is explained in depth as to why or why not they are the correct answer. This question is particularly difficult, and not all quizzes will need such extensive solutions. You may also come across some questions that are more calculation-based than theory, so it may become more difficult to explain why each answer is right or wrong. In these cases, what you should do is you should make other options correlated to the answer somehow. Let me give you a few examples. If the quiz asks to find the price of a good, in that case, you can put a possible answer as the quantity. So the students who don't complete the question at the right step or misread the question will be thrown off, and then they can see where their mistake was once they read the solution. Maybe the problem asks for gravity, but because students have to determine themselves which direction they need to set the gravity to, altering the sign of the final answer, for example, you'll have the value x and the value negative x, will give the same tricky effect. In these two examples, you can easily explain how each wrong answer correlates with the right one because you'll have made it that way. Another possibility is to make a chart with all of the options and their associated values to see the correlation between them. There are many, many possible ways you can go effectively about solving quizzes. You just have to get creative.
After creating concepts, examples, and quizzes, as well as proofreading them, it's time to put them together into models. They are super easy to make. Let's click on Content on the navbar and go to CEQ. At the bottom left corner, let's click on New Model. The model requires several fields to be filled in. The name, which is the most important part of the model because models are going to be reused across universities. Therefore, the model needs to be easily searchable. For this particular example, we're going to look at the measurement uncertainty in physics. So we'll just call this uncertainty in measurement. And the next field is the subject, which needs to be filled in, which is obviously physics. And the description, which should contain three things: an introduction to the model, a brief explanation, and the importance of it. Here we'll just fill in the filler sentence just for the interest of time. This discusses error in measurement. Just be really quick. And then now on the left-hand side, we can add our various concepts, examples, and quizzes. Just as with links, you need to fill in with the appropriate CEQ IDs. You can add as many concepts, examples, and quizzes that you want, but know that they will appear in the order that you input them, with all the concepts appearing first, all examples second, and all quizzes last. I want to create a model with concept number 391. And with example 677. If I were to accidentally add another example by mistake, all I have to do is just erase it from the field and it won't be saved. Now I click Save, and the model should be created. After creating one or many CEQ models, it is time to create a complete package targeting specific university courses. For example, Mat 136 or Bio 130 at the University of Toronto. Each package consists of various learning models as previously introduced. Now, let us go over a couple of steps before your first package is laid out. First, click Packages, and then choose New Package. You'll be taken to the package page. Now it's time to start filling in some information. You can input the name for this package. For example, if you're creating a package for Mat 135, you can type in the name of this package. And since we're going to be covering, let's say, a midterm, we want to specify that as for so. So I'm going to call it Calculus 1, or A, which is the official name of the course, and the midterm. We're going to say that it's for calculus, and that the corresponding school is the University of Toronto, that the course code is Mat 135. Now we can choose to upload some exams. This will be a coalesced PDF file that you should create on your own time. So this should contain all of the past exams in the last 3 to 5 years or so. And then a formula sheet, which should be created by the end of the project. Now it's time to write a description. What this package you're creating focuses on, and what techniques and tools we introduce and demonstrate within the package should be what fills in the description. Before you start filling it in, you should edit the content on a separate text editor to make sure all the parts are written correctly in detail. So here, since we're just going to create a simple package with 2 items, we're going to say that the midterm is going to cover the extreme value theorems and mean value theorem. You can now move on to the left side of the page to start filling in the various models that you'll need to create the package. All models have ID numbers just as the CEQs do. I know that I want model numbers 6 and 15, which are going to cover the extreme value and mean value theorems, and include it into my package. Pay attention to the checkmark boxes here, as these indicate whether they're important for the final exam or not. And since they are, I'm going to click them. You can continue adding as many CEQs as you need and as many as necessary to complete the package. After you finish adding the models, click the chart in order to add what kind of information will be displayed on the Vobii student page. The chart will have a clear indication of the percentage of different topics that were covered on the past exams on the student side, and they see a complete chart, which shows what the student should expect most of the time studying in order to achieve the best outcome for the exam. 2 sections need to be filled in. Labels, which are labeled Module 1, 2, 3, 4, 5, and so on, which we can rename ourselves. For example, we're going to say that these are called the extreme value theorems. And mean value theorems. There should be more than this, obviously, but we're going to use this for the sake of time. After filling in the label section, you can scroll down to fill out the various percentages that you're going to be using. Each number corresponds to each data value in the array. For this example, let's assume that the exam will have a 50-50 split between the extreme value theorem and the mean value theorem. Therefore, we're going to say that we have a 50-50 split here. You're now done with the chart creation. Double check everything at this point that you have everything created, and now save.